So for this question, endothermic means that heat is taken in because sounds like enter. So the answer is C. Rather straightforward. Next one, endothermic. So let's take a look at what we have here. So endothermic means taking in of heat. Condensation. Condensation means gas to liquid. So gas to liquid means we are trying to increase the forces of attraction. They are trying to come closer together. Means it's similar to bond forming. So condensation gives off heat is talking about bond forming. Same for solidification. Solidification is from your molten. Molten that means liquid. So from your liquid to solid. So again, same thing. They're trying to make the particles go closer together. So because of going closer together, it's a bit similar to bond forming, which means it's exothermic. Okay, then for option C, dissolving sodium hydroxide. Sodium hydroxide is an alkali, not an acid. So this is something that you wouldn't know. So we move to the last one. Sublimation means solid to gas. Here we are trying to get the particles to be further apart. We are trying to overcome the forces of attraction, which is similar to bond breaking. Therefore, it is taking in heat energy. So answer is D. Okay, this question is similar to the previous worksheet. We have the same substances here, but instead here they're asking about endothermic. So a quick explanation would be that this is solid to gas, sublimation. This is solid decomposing into two. Both of these fall under endothermic. For here, which is burning combustion, this falls under exothermic. So in this case, option C is the answer. If you would like a more detailed explanation, you can go back to worksheet 1. Okay, here they're asking for endothermic again, talking about heat being taken in. So we have all the state symbols and let's see which is which. Gas to solid. Gas to solid is under solidification. The particles are coming nearer, talking more about bond forming in that sense. So it's exothermic. Solid to liquid is melting. It requires heat. You need to take in heat for it to melt. So it's endothermic. Okay, because solid to liquid, we are trying to overcome the forces of attraction. Next one, option C, gas to solid is similar to solidification. And option D, liquid to solid, this is freezing. So freezing, you're trying to let the particles go closer together. So it's more like bond forming, so it's exothermic. So of all four, the only one that needs heat to be taken in to cause the particles to go further apart in terms of bond breaking is option B. Therefore, option B is endothermic. In this question, it says endothermic and what is the correct change in temperature. So when we talk about endothermic, we recall that it's all this over here. So I write it down. Takes in heat from the surrounding, so the temperature of the surrounding will drop. And finally, when the reaction is complete, it will go back to room temperature. So we're talking about dropping in temperature. So it's either C or D. And because after a while, the temperature of the mixture will return back to room temperature, therefore option is D. Okay, next one. So this is based on remembering what processes are endothermic. So processes that are endothermic are either all the physical process, where we move from solid to liquid, liquid to gas, or solid to gas, where we try to overcome the force of attraction, trying to break the bonds, or when we dissolve soluble salts in water, or thermal decomposition. So we take a look at 1, 2, 3, 4. Okay, option A, B, C, D. The one that is matching one of these over here is dissolving ammonium nitrate in water, because all spar salts are soluble. SPA stands for sodium, potassium, and ammonium salts. So ammonium nitrate is a soluble salt. If you would like to know further, adding sodium to water, this is not what you have learnt. Okay, and we talk about oxidation. This is exothermic, and we talk about reaction between hydrogen and oxygen. This is oxidation. So again, this is exothermic. Okay, question 7 talking about endothermic. So endothermic heat is taken in, temperature falls. So therefore, answer is B. Okay, for this question, they show the change in temperature, and there is the positive values and the negative values. Okay, based on whether the final temperature is more than the initial temperature or is less than the initial temperature. So first thing I'll write down is change in temperature is final minus initial. So since it's a positive number means my final temperature is higher, negative number means my final temperature is lower, and so on. So based on this, once I know whether the final temperature is higher or lower, I can decide whether is it exo or endo. So the final temperature is higher means it's exo, endo, endo, and this will be exo. Okay, then what do I look next? It says which row of the table describes the energy changes. Okay, so let's see. W, exo. So this is wrong. X, exo. Wrong. X, endo. Yes, endo. How about Z? Z, exo. Yes. So this is the one that both is correct. Okay, so therefore, your answer is C. So again, this question is similar to worksheet 1. So here we are talking about chemical formula of sodium carbonate. So to balance the charges, we need 2 sodium. So you get Na2CO3. For potassium nitrate, the charges are balanced, so you get KNO3. Now we look to the next part. Okay, and they ask you for the temperature change. So 35 minus 30 gives you 5, positive, because the final temperature is higher. And this one gives you 8, minus, because final temperature is lower. So remember, temperature change is final minus initial. You need to have your plus and your minus and your degrees Celsius because it's not stated here. Okay, now they ask you a question. State the type of energy change that takes place when potassium nitrate dissolves in water. So if you recall that potassium nitrate is a soluble salt, it would be an endothermic reaction. Of course, we could go by the temperature. So my final temperature was lower. That means my final temperature dropped. Okay, final temperature dropped. So it's also endothermic. So what we say there is endothermic reaction. Okay, they didn't ask you to explain why over here, so this is just an additional information. But however, they ask you to explain why in part B. Give a reason for your answer. So there was a decrease in temperature of the solution, which means heat was taken in. So there's a set of results here. So right away when I see a set of results, I may want to decide whether is it exo or endo. So the final is higher, which means my temperature increased, which means it's exo because heat is given off. And my final temperature here is lower, which means temperature decrease, which means it's endothermic, whereby heat is taken in. So now we look at the question. Which reaction is an endothermic one? So it will be experiment 2. Okay, because there was a decrease in temperature of the system or the solution or surroundings, doesn't matter. Okay, which means heat was taken in. So next one, in the space below, you need to sketch a temperature against time graph. So for endothermic, temperature will be dropping and then going back to room temperature. So how can we draw this? So temperature in this case is degrees Celsius. Time, we can use minutes. And here, because of the temperature drop, my room temperature should be higher, 25 degrees Celsius. And at the end, I had a 15 degrees Celsius. Okay, so you may want to put slight lines around so that you can get the angle right. So it will drop down first, and then after a while it will go back up. Okay. Next, how will we differentiate between an endothermic reaction and an exothermic reaction? Most important that we can observe is the temperature. So what we would do is we would measure the change in temperature of the system by using a thermometer. And what happens? So let's say it's an endothermic reaction. What would be the result? The result is there will be a decrease in temperature of the system or reaction mixture. Okay, and for exothermic reaction, there will be an increase in temperature. So based on whether the temperature decreased or increased, we can tell whether is it endo or exo. So we measure that change in temperature using a thermometer.